So we're going to solve some equations, but we're going to solve these equations using something called U-Substitution. It's simply called U-Substitution because traditionally mathematicians would use the variable U to represent something else in the problem. And so if I look at the equations before me, and there's 6 of them, I will probably do 2 videos, 3 and 3. So when we look at these equations, one of the things that jumps out to me is most of them have something to the 4th power raised and something to the 2nd power. Something to the 4th, something to the 2nd. And here's the deal. I have no idea how to solve something that's raised to the 4th power, but I have a lot of practice with solving quadratics. And so generally what you do with these problems is you actually turn them into quadratics, solve the quadratic like you would normally, and then take it one step further. So let's put this in practice and see what it's going to look like. I'm going to go ahead and zoom in on number 1 here. Apparently I'm also going to make the screen freeze. Sorry about that. So number 1, you've got y to the 4th minus 7y squared plus 6. So because we're dealing with y to the 4th and y squared, what I want to do is actually turn this into u squared and 7u. So what that means is that what I said for this problem is that u is equal to y squared. All right, I'm basically simplifying the problem to turn it into something I can solve. All right, so plus 6 is equal to 0. And so at this point, I'm going to temporarily forget that this part exists and just solve this equation. So u squared minus 7u plus 6, this is factorable. So u minus 6, u minus 1. Which means that u minus 6 would equal 0, u minus 1 would equal 0, which means u equals 6 and u equals 1. Okay, so far so good. That's just solving a quadratic. But we need to remember that in the original problem, we didn't have u's. We had the variable y. And so each one of these u's is going to get replaced with y squared. So y squared is equal to 6, and y squared is equal to 1. So this is the part we're going to take it that steps further. All right, we're going to keep going now and actually solve for y in the problem. In both of these little miniature equations, I'm going to take the square root of both sides. And so I would have on the left side here, y is equal to plus or minus root 6. Just leave it as is, it's okay. And then on the right side, I'm going to take the square root, and y is equal to plus or minus 1. And that is your answer. Actually, I should say those, if I'm being grammatically correct, because it's not one answer, it's not 2 answers, it's actually a total of 4 answers. You've got plus or positive root 6, you've got negative root 6, so that's 2 answers here. You have positive 1 and you have negative 1, so that's 2 answers here for a total of 4 answers. Okay, so I'm going to go ahead and do the odd problems. So this was number 1. Let's go ahead and slide on down to number 2 here. Now at number 2, I've got x to the 4th and x squared. Unfortunately, this is not written in standard form, so I want to write it in standard form first. And so you've got x to the 4th minus 2x squared minus 35 is equal to 0. So my initial thought when I'm doing this is, again, I don't want to have x to the 4th and x squared. I want to turn this into a quadratic, okay, which means that the x squared here got replaced with u. And so this is my little, let u, wow, let's actually put that into some letters that make sense. So let u equal x squared, so that way later on we know what we're actually solving for. Take a minute or 2 and factor away. So u minus 7 plus 5, which means u is going to equal 7 and u would equal negative 5. Okay. If you need a reminder, this is u minus 7 equals 0 and u plus 5 equals 0. Reminder, we weren't solving for u in this problem. We were supposed to be solving for x. So each of these u's is going to get replaced with the x squared that we originally replaced. All right, so it's kind of replace and then replace back, or substitute back. So we've got x squared is equal to 7, and x squared is equal to negative 5. So that's nice. Square root both sides. So x is equal to plus or minus root 7. If you can't reduce your radical, leave it. And x is equal to plus or minus. Now, this one I can break up. So I'm going to break it up as negative 1 and 5. Negative 1 times 5 is negative 5. And so this would become x is equal to plus or minus. Now, again, depending on how you write your radicals, depends on how you maybe want to write this answer. Mathematical convention, the number comes first, and then you put I at the end, because by definition, the square root of negative 1 is equal to I. All right. I think I've mentioned this in a previous video. I have a horrible habit of writing my roots way too long, and so separately, or I would actually probably write this as plus or minus I root 5. Those are the same answers. So don't feel like you have to put it the way I do. The actual true way to write it, the mathematical way, is this way. But like I said, I have a bad habit of extending that root way too long, and so I end up writing it this way. So it's very clear that the I is not under the square root when I don't want it to be. So that was number 3. Let's take a look at number 5 and see what kind of fun that has for us. So we're not in standard form. So let's get it in standard form. So 10x to the 4th plus 3x squared minus 1 is equal to 0. And we've got, again, x to the 4th and x squared. I'm not a huge fan of that. So let's go ahead and say that u is going to equal x squared. So this would become 10u squared plus 3u minus 1 equals 0. I am pretty sure I can guess and check my way through this one. So 5, whoops, that's supposed to be a u. Let's make that 2u, 1 and 1, plus minus. Okay, quick check. 5u times 2u is 10u squared, plus 5u minus 2u is 3u minus 1. Yeah, all right. So I've got the correct factors at this point. I'm going to take each factor, set it equal to 0, okay, and I'm going to solve them. So 5u equals 1, which makes u equal to 1/5. We've got 2u is equal to negative 1, and then u is equal to negative 1/2. Okay. But again, we weren't supposed to be solving for u in this problem. We used the u to try to make the problem simpler. All right, I know how to solve a quadratic. I can do that. And so that's what I used. However, we are actually going to replace each one of these u's with an x squared. So x squared is equal to 1/5, and x squared is equal to negative 1/2. Now, I already know what's coming next, so I know how large I write, and so I'm going to give myself some space. Don't fear, we're going to walk through this, all right, but we're going to take the square root of both sides. And when we take that square root, we're going to get x is equal to plus or minus, and this is where it's going to get a little weird, okay? The answer is the square root of 1/5. However, that is not considered to be simplified. If you've ever done something called rationalizing the denominator, that's what we're going to do. To rationalize the denominator basically means you're going to remove the radical, in this case the root 5, from the denominator. Now, you don't just get to take an eraser and erase it. Sorry, that's not how it works. But what you can do is multiply your denominator by itself. But what you do to the denominator, you need to mirror into the numerator. Okay? So x is equal to plus or minus. Now, what's happening here is we're going to deal with this in pieces. So I've got root 1 on the top times root 5. So that's just going to be root 5. And in the denominator, we've got root 5 times root 5, which would be root 25. What's the square root of 25, do you think? Because I'm pretty sure the square root of 25 is just 5. And so the rationalization process gets us a fraction with an integer denominator as opposed to a fraction with a radical denominator. And so that's where we want to take this answer to. And so x is equal to positive or negative root 5 over 5. Okay, so that's if you had x squared is equal to 1/5. I'm going to do something similar with x squared is equal to negative 1/2. All right, so again, we're going to square root both sides. All right, this one's an extra special treasure because we have positive or negative. Because it's a negative underneath the radical, we have an I that we need to deal with. So I'm going to go ahead and pull that out of the 1/2. Okay. Again, not a big fan of having the root 2 in the denominator, so to rationalize it, multiply by root 2 over root 2. And let's clean this mess up. So plus or minus I. All right. Root 1 times root 2 is root 2. And then root 2 times root 2 is root 4. And then the square root of 4 is just 2. So you'll notice I wrote this the way I tend to write it. I will quickly remind you the mathematical convention actually says you would do that. So whichever method you do it, I did take the box off the one I put an answer. It's up to you which one you answer. I will accept either. Again, you just want to be careful that your square root is not covering that I value. All right, so I'm going to pinch in so you can see this one from top to bottom. So we started by writing it in standard form. We replaced the x to the fourth and x squared with u squared and u to turn it into a quadratic. Factored the quadratic, solved the quadratic. At this point, then, we want to re-substitute or reverse the substitution back to the original problem. In this case, it was the x squareds. Solve. So square root both sides, rationalize if needed. It won't always be, all right? Same thing over here. We have x squared is equal to negative 1/2. This is imaginary. If it's imaginary, we're going to deal with it, okay? Plus or minus I root 2 over 2, or plus or minus root 2 over 2 times I. This is, again, the mathematical convention. I will accept this if you think you're going to run into the same issue I have. I'm going to go ahead and close this video, and I will pop up a second video that goes through questions 2, 4, and 6. As always, if you want to try those on your own and then watch the video to see if you've got the right answers, that would be a fabulous idea.